Alright, so in this problem, I have 8 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting my equation here. So my equation is 8 to the power of x is equal to 16. Now, before we start doing anything, let's just inspect this problem real quick. So if I plug in x equals 1 into this equation, I get 8 to the power of 1 is equal to 16, which 8 to the power of 1 is the same thing as 8, so I get 8 equals 16, which is false, right? Now if I plug in x equals 2, I get 8 to the power of 2 is equal to 16, and 8 to the power of 2 is 64. So I get 64 equals 16. And notice how there's a big gap between 8 and 64. So we know that the value of x is not going to be a whole number but a decimal, and it's going to be somewhere in between 1 and 2. So x is greater than 1 but less than 2. We know this. Now, how are we going to actually solve this problem and find the exact value of x? Well, what I can do is rewrite 16 as 8 times 2. Now what I'm going to do is divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 2. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1 is equal to a to the power of x minus 1, which is equal to 2. Now a is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x minus 1 is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1 is the same thing as 2 to the power of 3 times x minus 1. And 3 times x minus 1, I can distribute 3, so I get 2 to the power of 3x minus 3 is equal to 2. And 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So this means that 3x minus 3 is equal to 1. And now if I add 3 on both sides, I get 3x is equal to 4, and x is equal to 4 over 3. Now, there actually is another way to solve this problem. What I can also do is at the start rewrite both of these in bases of 2. So 8 is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x, and 16 is the same thing as 2 to the power of 4. Now this is the same thing as 2 to the power of 3x is equal to 2 to the power of 4, meaning that 3x is equal to 4, and x is equal to 4 over 3. So this is a much simpler method of solving this problem. Alright, so in this video, I'm going to solve the equation x to the power of x to the power of 4 is equal to 64. So the variable I want to find the value to in this equation is x. And for my solution, I'm going to first start by taking the power of 4 on both sides. So I get x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. However, m and n are interchangeable, meaning this can also be written as a to the power of n to the times m. Now if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m, this should be equal to a to the power of n to the power of m. So x to the power of x to the power of 4 to the power of 4. In this, I can think of x to the power of 4 as m and 4 as n. So this turns into x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now 64 to the power of 4 I can rewrite as 8 squared to the power of 4, which turns into 8 to the power of 8. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, x to the power of 4 is equal to 8. And to solve for x, I'm going to take the fourth root on both sides. So I get x is equal to positive or negative fourth root of 8.